Okay guys, this is the note or video about rules for derivation, or differentiation I should say. First thing is, the derivative of anything that's constant is 0. And again, it's only if it's just constant, I should say. If it's attached to a variable, it is not. So that's saying that the derivative of f with respect to x would equal d of dx of a constant. And if that's the case, then it's just 0. So for example 1, find the derivative of the constant f of x equals 3. Well, that'd be f prime of x is equal to 0. And again, it makes sense because this is the line y equals 3. What's the slope of the horizontal line? It's 0. So this next one is the power rule. Basically, if you have something to the nth power, you take the n, or the power, you multiply it down in front, so it's n times whatever else is there. So it could have a constant in front, and you'd have to multiply those. And then x to the power below, so n minus 1. So find the derivative of x to the fifth. So y prime would equal, if you multiply the 5 down times 1, it's 5x, and then 5 minus 1 is a 4. Okay. A constant multiple just means that you can separate the constant and then take the derivative of the thing that you're taking the derivative of. So for this example, we can say y prime is equal to 3, and then when you take the derivative of u, you get u prime. The reason why I say that is most of the time we take the derivative with respect to x, and when we do that, the x prime goes away, if you want to think of it like that. It just becomes 1. But if you're taking the derivative of something else, you need to then have its derivative shown, because we don't know what the derivative of that is with respect to x, if that's the case. But if it was y equals 3x, then it would just be 3. So, alright, next one. This is basically saying if you have two things that are added together or subtracted, you can take the derivative of the individual pieces and then just rewrite it as, so take the derivative and then add and subtract them. So find the derivative of p with respect to t of t cubed plus 6t squared minus 5/3 t plus 16. Well, p prime is going to be, you multiply the 3 down, you get 3t, this goes 1 less, so 2. And then, so we took the derivative of the first piece, plus we can take the derivative of the second piece. We get 12t minus, if you take the derivative of this is just 5/3. Again, it's not times t prime because we're taking with respect to t, so it's just 5/3. And then the derivative of just a constant, 16, is 0. So that is our answer. And now we can use this information to answer questions. Does the curve y equals x to the fourth minus 2x squared plus 2 have any horizontal tangents, and if so, where? Well, again, horizontal tangent, you have to think about the slope of that tangent. A horizontal line has a slope of 0. Okay, so we need to find the derivative to tell us the slopes of the tangents. So I'm going to do y prime is equal to 4x cubed minus 4x, and then the derivative of 2 is 0, so that is it. And then we're going to take that and say, well, I want to know when the derivative or the slopes are 0. So I'm going to put a 0 in for y prime, because that represents the slope of the curve, and then solve for x. We can factor out a 4x, and we're left with an x squared minus 1. We can factor that more by using difference of squares. So we get x is equal to 0, x is equal to negative 1, and x is equal to 1. Okay, so the corresponding points, so at those 3 points on the curve, you will have a horizontal tangent of and the corresponding points are, if you stick 0 into the original equation, you get 0, 2. If you stick negative 1 in, you get 1. And then if you stick 1 in, you also get 1. Okay, so those are the 3 spots where you have a horizontal tangent. Okay, so now let's go on to the next page. So up here, this is showing you that you cannot just multiply the two things or take the derivative and then multiply them. It doesn't work out. Because if I have x times x, that's x squared. And if I take the derivative of x squared using the power rule, you get 2x. However, if I try to split it up and take the derivative first of each one, you get 1 times 1, which is 1. Those don't equal. So in order to take the derivative of two things multiplied together, uv, you have to take one of the pieces and then multiply by the derivative of the second, and then add that to the second piece times the derivative of the first. So for this problem here, I'm going to call this u, and then I'm going to switch colors on us and call this v. So it's u dv dx plus v du dx. So we have u and v. I'm going to just write down what the other pieces are. So du dx, if I take this piece, the red piece with respect to x, I get 2x, and that's it. If I take the piece dv dx, take the derivative of that inside, you get 3x squared, and again, that's it. The plus 3 doesn't matter. So I can now write out my derivative. F prime of x is equal to u dv dx, so u is x squared plus 1, times dv dx, which is 3x squared, plus v, which is x cubed plus 3, times du dx, which is 2x. Okay? As we get going to chain rule, there will be chains where you can just leave them alone. This is technically the derivative, but you also need to be able to simplify if need be. So if you need to simplify, this would be 3x to the fourth plus 3x squared plus 2x to the fourth plus 6x, which turns into 5x to the fourth plus 3x squared plus 6x. Okay? So that is how you do the product rule. Quotient rule, you also cannot just take the derivative of the top and bottom and divide. You have to use this rule for it to work. I have a little saying over here, low d high minus high d low over the square of what's below. That kind of helps you. So we have low is v, so because it's the lower piece, times the derivative of the high piece, that's what d high means, minus high, which is the u, times d low, or derivative of v over what's below squared. Okay? So let's try that with this piece. Find, and here's when you know you'd have to do this. Sometimes it's easier to simplify, as you'll see on the next one, but we really can't simplify this fraction at all. So we're going to take the derivative using our quotient rule. So this is u, this is v. I'm going to just write what the derivative of u and v are so I have them. Du dx is equal to 2x, because I took the derivative of the top, and actually the derivative of the bottom is also 2x. So now I put it into my formula. So f prime of x is equal to low, which is x squared plus 1, d high, which is 2x, minus the high piece, which is x squared minus 1, times d low, which is 2x, over x squared plus 1 quantity squared. You can leave the bottom the way it is. Let's try to simplify the top a little bit. We get 2x to the third plus 2x minus 2x to the third, and then that becomes a plus 2x, because you have to distribute that negative in there. Don't forget to distribute your negatives. So we get 4x on top over x squared plus 1 quantity squared. Okay, so that is how you can use the quotient rule. Finally, we can also we do power rule with negative exponents. Now, for this one, some of you guys might go, oh, well, we can do the quotient rule. And you can, and you would get the correct answer. However, because there's just one term on the bottom, it might be easier to simplify y into two fractions. So we get x squared over 2x plus 3 over 2x, which we can rewrite even further as that's a constant of 1/2, and then if you cancel the x's, we just have that, plus 3/2, and then if you bring this x up, you can only do power rule if x is on the top, so this is going to be x to the negative first. So now I'm going to do just power rule. So this is a little bit easier than quotient rule. 1/2 x, x to the first. If it's x to the first, you get a derivative of just 1/2 for that piece, plus you bring the negative 1 down, you get a negative 3/2 x, and then be careful, it goes to negative 2. So if I rewrite this with no negative exponent, I have 1/2 minus 3 over 2x squared. And you would get that if you did the quotient rule as well. Okay, so those are all the rules for differentiation.